Hello, welcome again. We are covering the topic centrifugal compressor for civil services mains, IFS and Gate Aerospace exam. So the next subtopic in the main topic centrifugal compressor is principle of operation of centrifugal compressor. So first of all, this is the schematic diagram of the centrifugal compressor. Okay. It is enclosed in a casing and this impeller rotating part and diffuser are the main part of the centrifugal compressor. Okay. So this part is your impeller eye. The air is sucked axially, you can see axially, and then move radially outward to impeller tip, and at this point it enters the diffuser tip. So this is the working of the centrifugal compressor. So I will read the point wise and explain more. First point is the centrifugal compressor consists essentially of a stationary casing containing a rotating impeller which imparts high velocity to air. So this is your impeller. It imparts high velocity to air and is number of fixed diverging passages in which air is deaccelerated with a consequent rise in static pressure, hence called diffuser. So this is your diffuser. These are the diffusers. What is diffuser? This is impeller. Here high velocity is imparted to the air and there is some pressure rise also, static pressure rise, and here these are fixed. So here only the static pressure rise takes place and that is at the cost of velocity. So velocity is decreased here and static pressure is increased here in the diffuser. So reading out again, the centrifugal compressor consists of essentially of a stationary casing containing a rotating impeller which imparts high velocity to the air and is number of fixed diverging passages in which air is distributed with a consequent rise in static pressure, hence called diffuser. Figure shows a diagrammatic sketch of a centrifugal compressor. Impeller eye may be single or double sided. As shown in figure BLC, double sided impeller is used for high flow rate. So here this is your impeller eye and its side view is this. So air may enter from one side or it may enter from both sides, this side and this side. This is the side view. Here air is entering and then going readily, and here air is entering from this side and from this side. So this is double sided and this is your single sided. So this is the part. This is your impeller eye. It can be single sided or it can be double sided. Air can enter from here also and here also. Air is sucked into impeller eye and whirled around at high speed by the vanes of impeller disc. So air is entering here and then it moves radially, entering actually but moving radially, and while its motion in the radial direction, the impeller also imparts the whirl velocity. So its velocity is increased by the impeller because this is the rotating part of the centrifugal compressor. Air is sucked into impeller eye and whirled around at high speed by the vanes of impeller disc. At any point in the flow of air through the centripetal acceleration is obtained by the pressure head, so that the static pressure of air increases from I to 34 the impeller. So here as air is moving readily outward So this velocity is also being imparted by the impeller to the air. So it will cause some pressure rise as well as velocity rise of the air. So here there is some static pressure rise and also some velocity rise. Okay, so that is due to the action of impeller. So impeller increases both pressure as well as velocity. So it is because impeller is imparting energy to the air, so that energy can be in the form of velocity or it can be in the form of pressure or both. So in this case the energy is in the form of both. From here to here the pressure also rises, from here to here the velocity also rises. Okay. So air is sucked into impeller eye and whirled round at high speed by the vanes of impeller disc. At any point in the flow of air, through centrifugal extraction is obtained by a pressure head, so that the static pressure of air increases from eye to tip of the impeller. The remainder of the static pressure rise is obtained in the diffuser, where the very high velocity of air leaving the impeller is reduced to somewhere in the region of velocity with which the air enters the impeller eye. So now after the impeller there is diffuser, and diffuser is not imparting any energy to the air. It is changing kinetic energy to pressure energy. So here the kinetic energy is reduced and pressure energy is increased. So here both pressure energy as well as kinetic energy is imparted to air by the impeller because it is rotating, and kinetic energy of this impeller is imparted to air, which is in the form of pressure energy as well as in the form of kinetic energy of air. So kinetic energy of impeller is imparted to air, so which is in the form of kinetic energy as well as pressure energy. But here there is no rotation of diffuser, so diffuser is not imparting any energy to the air. It is just changing the kinetic energy to pressure energy. So here the static pressure rises, but it is at the cost of kinetic energy. So kinetic energy decreases. Kinetic energy. The remainder of the static pressure rise is obtained in diffuser, where very high velocity of air leaving the impeller tip is reduced to somewhere in the region of velocity with which the air enters the impeller. So the air is entering here in the impeller eye with some velocity, and the leaving velocity is also the same as it is reduced by the diffuser. So here the velocity increases and then it is decreases, then it decreases and comes a value near to the entrance velocity. It should be appreciated that the friction in the diffuser causes some loss of stagnation pressure. There is some loss of stagnation pressure, but static pressure rises. Stagnation pressure is total pressure, that is dynamic pressure as well as your static pressure. Static pressure rises, dynamic pressure reduces, total pressure may reduce due to friction. Total pressure is dynamic pressure plus static pressure. So dynamic pressure may so dynamic pressure changes to static pressure here or total pressure, but total pressure may reduce due to friction in the diffuser. The normal practice is to design the compressor so that about half the pressure rise occurs in the impeller and half in the diffuser. So here we have stated that there is some pressure rise as well as velocity rise due to energy imparted to air. So here and here there is also some pressure rise at the cost of kinetic energy of air. So here it is the pressure rise in the static pressure rise